This video is for vertex form of a quadratic function. In our scenario, scientists are tracking the population volume of a specific type of fish. This fish population is in a certain part of the ocean and is measured in thousands of fish as a function of increasing the water's temperature in degrees Celsius, modeled by the function below. When graphing in vertex form, we are given key pieces of information about the graph and able to make a rough sketch. For this particular graph, in vertex form, our graph looks like such. A U-shaped graph with a maximum value of 200 thousands of fish, the fish population on the y-axis, occurring at 9 degrees Celsius, temperature degrees Celsius on the x-axis. And that is our sketch of the graph, pulling out the information from the equation of vertex form. Looking at the key features of a quadratic graph that we are interested in, h value, or x-coordinate of the vertex, k value, y-coordinate of the vertex, y-intercept, x-intercepts, increasing, decreasing, positive, negative, and a reasonable domain and range, we are going to go ahead and see whether we can answer and provide these features using our sketch of the graph provided from the equation. So, do we know the h value, or the x-coordinate of the vertex? Yes, we know this occurs at 9 degrees Celsius. What is the maximum number of fish, or the k value, or y-coordinate of the vertex? Yes, we know this is 200 thousands of fish. But what about the other features of the graph? What is the population of fish when the temperature is 0 degrees Celsius, or the y-intercept? This is unknown to us from our sketch of the graph. We do not know the exact y-intercept value and would need to do more work to pull it out from the given equation. We're unable to answer the y-intercept. What about the x-intercepts? Or in terms of the context of the problem, what temperatures in degrees Celsius will cause the fish population to be 0? Well, we once again do not know what this temperature or temperatures are using the quick sketch from our graph. We are unable to provide x-intercepts using the sketch from vertex form. What about where the population is growing and where is the population declining, or key phrases increasing and decreasing on our graph? Well, in order to determine whether increasing and decreasing occurs, we need to know the h value, or the x-coordinate of the vertex, which we have found up in part A. We can see the graph is increasing on this portion and decreasing on this portion. Using interval notation from a previous unit, we can say that the graph is increasing from negative infinity degrees Celsius to 9 degrees Celsius, and then begins decreasing from 9 degrees Celsius all the way up to positive infinity degrees Celsius. But what about where the population exists or has a positive y-coordinate? This comes from our x-intercepts. Or what about temperatures that would provide no fish, or where the population would be negative? Once again, this relies on our x-intercepts, which we are unable to find, so therefore we are unable to determine positive and negative since we do not know the x-intercepts of our graph. But what about a reasonable domain, or a reasonable range? For domain, we're wondering how far left, how far right does the graph go? But really, what temperatures in degrees Celsius make sense in this particular problem? Well, going to negative infinity all the way to positive infinity in terms of degrees Celsius doesn't completely make sense. But maybe we go ahead and look at this from 0 to 100 degrees Celsius. For reference in terms of Fahrenheit, this is from 32 degrees Fahrenheit when water freezes, all the way up to 212 degrees Fahrenheit when water boils. This is considered a reasonable domain for our scenario. What about reasonable range? How far down to how far up does this graph go? Or really, what population amounts make sense in this particular problem? Well, once again, going from negative infinity amount of fish all the way up to positive infinity amount of fish seems a bit crazy. Well, if we're looking at our graph, the graph looks like it goes down forever to negative infinity and only goes up to 200. Well, it doesn't make sense to talk about negative infinity fish, so maybe we cap it off at 0 all the way to 200, providing us a reasonable range from 0 to 200 thousands of fish. Well, looking back at all the key features that we were able to pull out of vertex form, we can see that vertex form can provide us a maximum or minimum value, the k value or the y vertex of the vertex, where the maximum or minimum occurs, which is the h value or x coordinate of the vertex. We can determine increasing and decreasing intervals, as well as think about a reasonable domaining range for our scenario. Looking back at the equation, we can note that the h value is found inside the parentheses next to the variable t, and our k value is added or subtracted onto the end. H value, k value. This is important information that we can use and rely on when we're trying to pull information and identify key features from vertex form.